everyone, this is Umakant Shrivastava, Assistant Professor Physics, Dr. C.V. Raman University, Kargi Road, Kota, Bilaspur, Chhattisgarh, India. Again, we are here on lectures of basics of nuclear physics, and our today's topic is what is nucleus. On hearing that word nucleus, we thought of an image that is like this. We know that nucleus is composed of protons and neutrons, and electrons are revolving around it. Nucleus are having different properties, but today's we are going to deal some of the properties, and the first one is nuclear charge. Nuclear charge is being represented by a notation Zxa, in which Z is the proton number, A is the atomic mass, and as X represents the element. Z is the proton number and it has charge plus Ze, whereas Z is the proton number and E is the charge of proton. Also, A minus Zn, that is A minus Z, sorry, that is the neutron number, is represented by N, and it has been assumed that neutron has no charge. So the total charge of a nucleus is being occupied by protons. The second property of nucleus is the nucleus mass, nuclear mass. The mass of an atom is given by the mass of nucleus plus mass of the electrons in it. Since the mass of electrons are very low as compared to protons and neutrons, so we can say that mass of an atom is approximately equal to the mass of nucleus. So we can write m nucleus, that is mass of nucleus, is equals to Zmp plus A minus Z Mn, where Mp and Mn are the mass of proton and neutron. So the whole mass of an atom is equals to mass of nucleus plus mass of electron. So putting the value of m nucleus from the first equation, we can get the m atom equation in final as m atom is equals to Zmp plus A minus Z Mn plus Z Me, where Mp, Mn and Me are the mass of proton, neutron and electron respectively. It is explained in the term of AMU, that is atomic mass unit, and the value of 1 AMU is 1/12 of mass of atom of carbon 12. The next property of nucleus which we are going to deal here is nuclear size. Nuclear size can be explained with the help of lighter nuclei and heavy nuclei example. In case of lighter nuclei, the A value, that is atomic mass, will decrease as the number of protons and number of neutrons decreases, whereas in heavy nucleus the A value, that is atomic mass, increases with the number of increasing proton and neutrons. So the volume is proportional to size. So V, that is volume, is given by 4/3 pi r cube, where since we assume that the nucleus has a spherical shape, thus 4/3 pi r cube is directly proportional to A or we can write r cube is directly proportional to A, where r is the radius of the sphere. R can also be written like this: r is proportional to A to the power 1/3. So the value of r is equals to r0 A to the power 1/3, where r0 is nuclear radius parameter and its value lies between 1.2 to 1.6 femtometer, where 1 femtometer is equals to 10 to the power minus 15 meter. The next property of nucleus which we are going to read is nuclear density. Nuclear density can be defined as the ratio of mass of nucleus and the volume of the nucleus. It can also be given with the equation, as we know that the mass of nucleus is given by A and the volume of nucleus is given by 4/3 pi r cube equation. It can be further classified into this equation by putting the value of r is equals to r naught A, and finally we'll got the value like this after putting the value of pi and after putting the value of r naught. In the next sequence we got the nuclear density 2.97 into 10 to the power 17 kilogram per meter cube. By solving this equation we'll got an approximate value of 10 to the power 17 kg per meter cube. So we can say on an whole we can say that on a practical basis, if a box of volume 1 meter cube is to be filled with atoms, then on complete filling of box the density will be approximately 10 to the power 17 kg per meter cube. So these are the topics which we have covered today. Thank you so much, and we'll come next time the further properties for the further studies. Thank you.